Hello everyone, welcome to our 10th week lesson. It already has been 10 weeks and today we're going to learn something fun. So last time we learned about binary code, how all the numbers or actually all data, files, videos, audio, text can be written in zeros and ones. And we learned about how to convert them into actually just numbers, numerical values into binary numbers. And hopefully you remember how to count binary number with, one hand. But anyway, today we're going to be talking about the following things. Oops. So today we're going to talk about mapping puzzle. It's a puzzle, it's going to be fun. Alphabets in binary, and I'm going to be deciphering binary. And we're going to do a little activity which will be used for next week's discussion group, okay? All right, moving on. Warm up. Try to decipher the following message. Pause the video and come back once you're done. Now, welcome back. So now when you see this, hopefully you realize that these symbols mean something, or usually maybe it's a shape, maybe it's a color, but hopefully you realize it's going to be color because why? All the shapes are the same, right? And hopefully you realize that each symbol represents a letter, right? So maybe this is red, and there are 3 symbols that make sense. Yellow has 6 symbols, which makes sense, and pink has 4 symbols. So maybe you thought each letter is like maybe R, E, D, red, right? You can confirm that by looking at other things. For example, this is E here. Is it E here as well? In this case, yes. What about here? Blue, hey, that works. So this is a thought process hopefully you followed, okay? So doing so, you get something like this, okay? So the answer is purple, so that the answer should be here, a purple color. All right, maybe that was easy. Maybe it was hard. Hopefully it was easy. I'm gonna do something else. Let's move on to the next. Binary language. So binary language, you can see 0 and 1s. And last time we talked about how numerical values can be written as binary, not decimal. In our everyday lives, we use decimal system, mainly because I think we have 10 fingers. But if we had 2 fingers, right, or 1 finger, right, I'm pretty sure we would be using binary system, right? But anyway, moving on. So let's look at these numbers. 0, 1, 1, 0, 1, 1, 1, oops, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. Oh, it's really hard to say. You can say if you want to, but I don't think there's a point. But how many binary codes do we have? Well, it depends, okay? But if you look at this, right? If you look at this, how many each numbers, how many digits are there? So let's count them up. So we have 1, we have 2, 3, 4, 5. I'm sorry, I'm writing 7 and 8, right? So each number has 8 digits. So do you remember what we call this? We call this 8 bits, okay? Because each digit represents what? A bit. A bit can hold either 0 or 1, okay? So this is 8 bits, okay? Oops, there we go. Whew. And guess what? Each 8-bit binary represents, in this case, a symbol or a letter or text. So in this case, this actually means hello. So in computer, hello is written in this form. You might think this is inefficient because, hey, what's the point of not writing H? But guess what? You got to understand this. Computers cannot understand letters, texts. It cannot. It understands binary, okay? At least for now, okay? All right, moving on. So what does that mean? It means each letter has its unique binary code, okay? And it's how many bits? 8 bits. So as you can see from A to Z, each letter has a unique what? Binary number. If you look at A to B, do you see that 1 has been added? And 1 has been added. So every time 1 is increased, okay? So let's go through this bullet points. Computers only understand numbers, 0 or 1. Okay, remember this is very important. Okay, now so what does that mean? Conclusion is that because computer does not understand anything but 0 and 1, we have to communicate with computer when you want to say something in text in zeros and ones. That's why people had to come up with a way to represent letters in numbers. And we call that ASCII system. We don't say that way. I'm sorry about that. I think it's called ASCII system. So it's called American Standard Code for Information and Interchange. Basically what it does is it codes our numerical representation of text in computers. Now, if you click on this table, you can see all the symbols in ASCII, okay? So example is this, it's 8 bits, remember that? So letter capitalized A, the number is 65, but 65 in binary is this in 8 bits, okay? Now, small case, lowercase a is not same as capital, okay? So capitalization matters, okay? So lowercase a is 97, okay? And you can see that it's unique. It's still 8 bits, okay? So do you have to memorize this? No, unless you really want to, but it's easy to find online. Binary puzzle number 1. The following message contains the age of different people. Now, if my video is blocking the message, I'm sorry. Decipher and determine the age of everyone. So we have person A, B, C, and somehow person A, B, C gave us this code just to represent their age. So note this, we're not talking about text, we're talking about what? Age. We're talking about numerical value, okay? So pause the video and try to review what we learned last time to decipher this message. Welcome back. Hopefully you had some time to think about, maybe even review previous lesson. But here is hopefully something that you thought of. So as you can see here, person A is dark, bright, bright, dark, bright, okay? And if you look at every other person, it's either dark or bright, okay? So hopefully you thought maybe dark means low, because low in brightness, right? So maybe this is 0, and maybe bright is 1, and this is 1, and this is 0, and this is 1, right? Right? Hopefully. So this is off, right? So we don't care about this, off, and this is off, and everything else is on, right? But we know that each digit represents power of 2s. 2 to the 0 power is 1. 2 to the first power is 2, right? But it's off, so it doesn't really matter. 2 to the second power is 4. 2 to the third power is 8. And 2 to the fourth power is 16. So basically what we have here is we have 5-bit binary numbers, okay? 5-bit. Because why? They're 5 digits. So guess what? Person A is what? You just add them up. 16 you don't add because it's off. 2 you don't add because it's off. But 8, 4, 1, you add them, you get 13. So that means person A is 13 years old. Okay. If you did not know how to do it, pause the video now and do B and C, okay? But if you already done it, you can continue watching. I'm going to show you the answer now. So the answer is, damn, there we go. Bam. Bam. There we go. Those are the answers, right? So yeah, binary can be written or symbolized in different ways, okay? So it doesn't have to be 1, 0. For machines, it's 1 and 0, but it can be different symbols. Now, puzzle number 2, right? An alien visited or visiting from Sirius system. Sirius is a star system near us. It's really bright, right? And left the following message for Earthlings like us that may help us to unlock their technology. Ooh, very exciting. Decipher the following message. Now let's count the number of stars. By the way, you can pause right now so you can do it on your own, but I can give you a little hint, okay? Now, a little hint. How many letters are there? Or how many characters are there? This first character is here, second, third, fourth, fifth. So most likely there are 5 characters, maybe numbers, maybe letters, we don't know. But let's count how many digits we have. 1, 2, 3, 4, 5, 6, 7, 8, I know my handwriting is really bad, but please know that I'm writing this on a trackpad. So yeah. So there are eight. There are 8 bits. Remember, 8 bits can be written as what? I mean, all the letters can be written as 8-bit binary. So most likely these are letters. So what I want you to do is go back and go to the table that contains all the letters and try to decode this. All right? Welcome back. Okay. If you haven't done it, it's fine, but I'm gonna show you the first one. All right. So dark is most likely 0. Bright, maybe 1. 0, 1, 0, 0, 0, 0. Right? So let's go back to the table. Give me a second. If you go back to the table, right? We had a bunch of zeros at the end. Yeah, here we go. 0, 1, 0, 1, 0, 0, 0, 0. It's P. You see that? It's P. So we know that the first letter is P. Now, if you now want to try, pause the video and come back. Welcome back. So the answer is, ta-da, psych. Anticlimactic, yes, but it must have been a hoax. All right. Now, exercise. Now, exercise I want you to do is write your name in binary code using the table in the link. So if you click on the link, okay, oops, discard, oops, it's okay. If you click on the link, you'll see, so if you click on the link, clicking, so we have a bunch of binary numbers, letters. You can find what letters you want in binary, okay? Okay, my computer is being slow, but it's okay. A lot of ads. Yeah, you can use it, okay? Ooh, computer, come on. I also, this link is good. What you can do with this link is this. I'll show you. Click on this link. And this is translator, okay? For example, I can say, coding is very fun, right? And then, so this is ASCII. By the way, don't worry about the encoding yet, okay? And convert. And there we go, all this. So computer can translate this into coding is very fun with capitalization of C, okay? So there we go. That's how computers understand, or not understand, but saves or stores textual data, okay? Now you might be thinking, hey, numerical values are binary, text value data is also binary. How does machine differentiate whether something is numerical value or text? Now you might want to think about this because there's a way to do it. For now, we're not going to talk about it. Last, what if I told you this meme is, I like it, but if you don't like it, it's fine, okay? Yeah, remember all the data, sound, video, text, numerical, any data can be stored in computer or stored in either 0 or 1s, at least for now. Because why? The reason I'm saying at least for now is because people are coming up with quantum computing, okay? Quantum computing will not only have 0 and 1s, but it's complex. You might want to Google it, YouTube it, because it's really cool. That it's over my head. Anyway, let's go into make app activity. So get your phones, tablets, or computer, whatever you need, and come back. All right, if you have opened up your make app, let's go to your project. Last time I asked you to do a project with, oh, here it is, bins for lazy person. And I said, hey, don't worry about making this bin, but if you want, you can do it. And hopefully if you did it, it was fun doing it, because this time I'm going to ask you to create something, okay? I'm going to explain to you very soon. All right. So remember, when you're creating a project, go to my project and create new one, okay? Got it? But anyway, this is the goal. Okay, we're trying to create a smart traffic light. We talked about some ideas, and I'll give you two ideas. Okay, but by the way, you do not have to follow these ideas if you don't want to. All right, method number one: using an ultrasound wave sensor. I want you to build and code so that the traffic light can turn green if a car or if an object is near the sensor for a certain period of time. Remember, there are two restrictions. Okay, number one, an object has to be within certain range. Okay, but also number two, it has to stay there for a certain period of time. The second part will be more challenging. Okay, think about how you can use if and else statements. Okay, to achieve this. Okay, also think about wait function. Okay, there's a wait function. Number two, using a button. Okay, so you build a code so that the traffic light can turn on green light if a car presses down the button for a certain period of time. So you might think, hey, there's no button on the road, but think about it. Under the road, you can actually put sensors, pressure sensor. So you can, so there's an actual case where they build it so that when cars, not just one car, when cars the waiting line gets long and they wait for a certain period of time, it senses so that it gives a signal to the traffic light, hey, you got to let them go now. Okay, so we're going to try to mimic those. Okay, the two methods I gave you, you do not have to follow this, so try to do one of them or both if you want to. So next time when we meet on Google Zoom meeting, I want us to share what you have come up with. Okay, if no one has done it, I'll show you one of these methods. I'll do it on my own. I'm going to show you. I'm going to even demonstrate whether it works or not using my own Arduino board so that we have fun. Okay? Thank you, everyone. I'll see you next week. Bye-bye.